Okay, let's quickly mark the last three that you had to do. So with this first one, I told you that we need to take over the 3. We need our function alone because then we are using a standard trigonometric graph. Okay, so it's the ones that we know. Now when we have a negative, I told you guys we're going to ignore the negative. We press shift cos of 2 over 3. And then I get my reference angle to be 48,1896. Okay, that is the reference angle. We always want to get a positive acute angle. But because we know that this answer was negative, we know that this angle is actually in the second and in the third quadrant. Now, how do I get into the second quadrant? I'm going to say 180 degrees minus 48,1896, which gives me an answer of 131,8 degrees. And then if I want to write a general solution, it's plus k times 360 degrees. Do you agree with that? But that will only be on the one side of the curve. You remember I showed you, no? Okay. So we need to find the angle on the other side of the curve. That one is going to be 180 degrees plus 48,1896. And that gives me an answer of 228,2 degrees plus k times 360 degrees. What do I need to write here as well? K, an element of integers. Always. If you don't write that, you lose the mark. Okay. But the question in the textbook, they only asked for the angles between 0 and 360 degrees. So I know it's only these two. Theta is going to be 131,8 degrees. And theta is going to be 228,2 degrees. Those are my two answers. Do you all understand? Did you get it right? It's not hard, ne? Okay. Next up, we've got 4 sin theta minus 3. So first off, I took over the negative 3. And it became positive, and then I divided with 4. So I've got a positive answer. So I'm going to say shift sin of 3 over 4. And then I get an answer of 48,59 degrees. This is a positive sin. So where is sin positive? In the first and the second quadrant. Do I need to do something to get into the first quadrant? No. First quadrant is an angle between 0 and 90 degrees. Is that angle between 0 and 90 degrees? Yes, so it's fine. So I just say theta is equal to 48,59 plus k times 360 degrees. K, element of integers. The other one is in the second quadrant. How do I get into the second quadrant? 180 minus, please, not 90 plus. 90 is cofunction. We don't use it. Then you're changing it to cos. You're going to mix it all up, okay? So it's 180 degrees minus 48,59. So I say 180 minus 48,59. It gives me an answer of 131,41 degrees. Plus k times 360 degrees. K, an element of integers. But they've only asked for the value between 0 and 360, so I know theta is only going to be 48,59. If you round it to 1 decimal, that's fine as well, no? And theta is going to be equal to 131,41 degrees. Those are my two answers. Did you get it right? Okay. Next up, I took the 0, ate 2 over, it became positive, and then I divided with 2. Okay? So I know tan theta is going to be equal to 0,41. So I just say shift tan 0.41, and then I get an answer of 22,29 degrees. Do you agree with that? Okay? This is a positive tan. Where is tan positive? In the first and the third. That is in the first quadrant. So I don't need to do anything with it. What does this one's general formula look like? Plus k times 180 degrees. Now you guys know why. The period of the tan graph is shorter. And then to get into the third quadrant, we're going to say 180 degrees plus 22,29 degrees. And that is equal to 202,29 degrees plus k times 180 degrees. And k is an element of integers. But the answer they want is only between 0 and 360. So I've got theta is going to be 22,29 degrees. And theta is going to be 202,29 degrees. Are you happy with that? You all understand? Okay. I need to show you something very important. Okay. This is still trigonometric equations, so it's not new work. But there's going to happen, something is going to happen now. So with the previous ones, we had, for instance, we only had the function sin and then my angle size equals to, you can just watch first, you don't have to write this down, equal to whatever number, let's say 2 over 3. And then what happened is we can have a value in front of the sin coefficient, or we can have something added to it or subtracted. So all we did was we took the thing being added over and we divided with the coefficient. Easy work. What's going to happen now is I'm going to get a function that looks like this. Sin a minus 24 degrees equal to negative 0,7. Okay. Now my problem is that I can't take that 24 over like I would have been able to take it over if it was added to the whole function. If I write plus 2 here, do you see the top one? At the top one, the 2 is added to the function. So 2 must be added to sin, what is it? Let's say this degrees is 30 degrees, whatever. We just pretend it's 30. So that 2 needs to be added to a half, for instance, if it was sin 30. With this second one, that 24 mustn't be subtracted from sin A. It must be subtracted from A, from the angle. You'll notice in the homework that we did as well, that thing being added or subtracted wasn't a degree. It was a value. It was a number. But when it's inside of the bracket, it's an angle. It's a degree. Okay. So 2 things can happen. It can either be added or subtracted, or it can be multiplied or divided with the angle. Okay. Now the difference is with these ones that are added to the whole function or multiplied with the whole function, those values you take over first, like we did here. But when that value is added or subtracted or multiplied or divided with the angle, you're going to take that over last in your final step after you've done everything. Okay, do you hear me? It makes sense. If you think about BODMAS, grade 8 sums, when we did it backwards, when we solved for x and x was in the bracket, that would be the last step you did, was breaking open the bracket where the variable is in. So it's not new, it's just in a trigonometric form now. Okay, so what we're going to do is, same way, nothing changes. You pretend as if that bracket is your whole angle, there's nothing being happening to it. So you're going to say shift sin 0.7, and then you get an answer that your reference angle is equals to 44,427 degrees. Do you understand that? But sin is negative. So where are these answers? In the third and the fourth quadrant. Right? So I've done nothing new. So I'm going to say my reference angle is going to be 180 degrees plus 44, the reference, equals to, and that gives me an answer of 224,427 degrees. A minus 24 degrees is equal to 22,427 degrees. Okay? Can I write the general solution? Yes. It's just the sin plus k times 360 degrees. Okay. Am I done? If there wasn't anything happening there, I would be done now. Right? So this would be the last step. Do you agree? And it's in this step that I go and subtract 24. Now tell me, if this was an algebraic expression and it looked like this, perhaps it was a minus 2 equal to 5 plus, let's say, 10x. And you took that 2 over. It becomes plus, no? Would you add it to the 5 and to the 10x? No, you would only add it to the 5. No, you can't add it to the 10x because it's a different term. They aren't like. So if I take that 24 degrees over and I add it, I can only add it to that one. Do you agree with me? I can't add it to 360 because it's 360k. It's not 360. Okay? So if I were to do this now in my last step, let me just erase this one. Now I'm going to say A is equal, I take that one over, I add it, 248,43 degrees plus k times 360 degrees. You understand that? So nothing changed. I just need to do that in the last step. Now I want to show you if it's being multiplied. I forgot the last quadrant, sorry. 360 degrees minus 44,427 degrees. That will give me an answer of 315,572 degrees. Okay? And then I know A minus 24 degrees is equal to 315. Can you guys still see? 315,572 degrees. Plus k times 360 degrees. So that 24 needs to go over, and it's going to be added. It's going to be equal to 339,57 degrees plus k times 360 degrees. That's it. Go. I want to show you what happens when I've got a coefficient with the angle as well, because then it's a little bit different. Cos 2a equal to negative 0,867. No, not degrees. Sorry. 867. You see the difference? Okay, it's not being added, It's not a 2 in front of the whole function. It's a 2 in front of the angle. So when the calculation is done to the angle, those are the ones I take over last. So there's nothing that I need to take over at the beginning. So I'm going to say shift cos 0.867. I get my reference angle to be equals to 29,888 degrees. Okay. This is negative. Where is cos negative? Second and the third. Right? How do I get into the second? I'm going to say 2a is equals to 180 degrees minus 29,888. That's going to be equals to, let me just write it at the bottom. 2a is equal to 150,1 degrees plus k times, what is cos? 360. I would be done now, right? Okay. I want to do, before I do that, I want to show you if this was a algebraic expression in grade 8. If this was 2x equal to, let's make it 16 plus 20y, and I were to divide with that 2, would I only divide it there, or would I divide it there and there and there, or just there and there? Where would I divide the 2? Huh? I would divide it everywhere. Do you agree with me? I would say that 2 cancels out, it becomes x. 16 divided by 2 becomes 8. That one becomes 10y. So what's the secret to mathematics? It stays the same, so don't do something different now because it's in trigonometry. The rules are still the same. So when I'm going to divide with this 2 here, and this one becomes a, that 150 is going to divide with 2. It's 75, it's 0.5. I'm going to round it off to 1. Plus k times 180 degrees. Okay. I'm going to show you graphically why this happens. I'll show you now. Okay. This is the one quadrant. Now I also need the other quadrant. 2a equal to, that other quadrant is going to be 180 plus 29,888, ne? So that gives me an answer of 209,9. I'm going to round off to, I can't round off yet, sorry. 888 plus k times 360. And now I can divide with 2 everywhere. So this becomes a. That one divided by 2 is 104,9 plus k times 180 degrees. Does that make sense? Okay, I want to show you graphically quickly.